Alright, hey guys. Sorry I got cut off last video. Miss Carmack walked in, and I'm so new to making these videos that it got stopped, so I do apologize for that. So just remember, when your scale factor is greater than 1, it's an enlargement. When it's n equals 1, it stays the same, and when n is smaller than 1, like a fraction, it's going to be a shrink. So sorry about that, and I now have found the pause button. So next time that happens, I know to pause it and not hit the actual icon, because when you hit the icon, it stops it like if you hit the stop button. So again, sorry about that. All right, so we are on slide 24, which is horizontal and vertical stretches. I'm going to be very honest with you guys. This is not on the ACT. So this is what I call fluff, and I don't do fluff. So when you guys are in class, more than likely I'm going to skip over this section, but I'm going to go ahead and give it to you guys who are remote because I haven't looked at the mastery test, so I do not know if horizontal and vertical stretches are on the mastery test. So just in case, to cover you guys and to cover myself, here's slide 24, horizontal and vertical stretches. All right, so we're going to click on our GeoGebra. Let's see what it gives us. Okay, so we got our pre-image, which is a triangle ABC. Looks like we're going to do a horizontal stretch, which means it just stretches out, to the right. And then vertical stretch is probably going to be up. Yeah, stretching up. Okay. Oh, it goes down also. Good deal. All right, let's see what we got to do. Okay, so move the horizontal and vertical slider to stretch the image of the triangle. When you settle on a pair of transformed images, record the coordinates on the images in the table. Be sure to list the coordinates in both the horizontal and vertical stretches. Also record the scale factor. Okay, that's your n, by the way. That's how much something gets bigger or smaller. Do this at least 3 times to fill in the table. Well, you guys know me. I'm going to make this easy on myself. So let's do a horizontal stretch of 2, scale factor of 2, and a vertical stretch, scale factor of 2. Basically, you're just multiplying by 2, but remember, you're only doing one of those. So here's the nitty-gritty. What you need to know, all you're doing is multiplying the x value, because it's an x, by your scale factor. So for you visual people, I'll show you. So I'm going to turn this into a 2. And I'm going to move this over. So here was your original 2, 1, right? So you only multiply the x value by the scale factor 2. So 2 times 2 is 4. 2. I'm right, my wrong one. There we go, 4, 2. So multiply 4 times 2, you get 8. Let's go to C. So 5 times 2 is 10. So it only affects the x if you're stretching along the x. There you go. Only affects the x if you're stretching along the x. So that is going to be 4, 1. And then we're going to multiply 4 times 2, so it'll be 8, 2. And then we're only going to multiply times the 5, so it'll be 10, 1. Pretty easy. All right, so let's see if we're doing a y, then you can imagine you only multiply the y value by the scale factor. So we're going to multiply 1 times 2, this 2 times 2, and this 1 times 2. But for you visual people, totally understand that. Let me show you. So put the x back where it was. So I want to get to my original image, that's the pre-image. Change this to a 2, and we're going to look here. So again, as you can see, the original was 2, 1. So the only thing we did was multiply that y value by 2. There's your original b. So multiply that y value by 2. That's the trick, you guys. That is it. So multiply the y value by whatever the scale factor is. So now it's going to be 2, 2. And that's going to be 4, 4. And that's going to be 5, 2. Easy breezy. All right, let's do a scale factor of 3. You know me, I like nice, easy numbers. Why make things difficult on myself? All right, so let me move this back. All right, for my visual people, I'm going to change it to 3. And because it's a stretch along the x, x is the one that gets multiplied. So 2, 1, and again, it's a scale factor of 3, so 2 times 3 is 6. Now it's 6, 1. All right, got 4, 2. X is the one that gets multiplied. 4 times 3 is 12. Now it's 12, 2. 5, 1. 5 is the x. That's the one that gets multiplied, so now it's 15, 1. Easy breezy. That's going to be 6, 1, 8, 2, and 10, 1. I'm sorry, 15, 1. My bad. Looked at the one above it for some reason. And that should be 12. There we go. I got a 6, 1 right? Yeah, there we go. All right, all right. All right, so this time we're going to multiply 3 by the y value. So it's going to be 2, 3. It's going to be 4. And 3 times 2 is 6. All right, 5 is going to stay the same. And 1 times 3 is 3. All right, let's make it easy. 4. So multiply every x times 4 and every y times 4 down here. So 2 times 4 is 8. Keep the 1. All right, 4 times 4 is 16. Keep the 2. And 4 times 5 is 20. Keep the 1. All right, this time I'm multiplying the y's times 4. So I'm going to keep the 2. And 1 times 4 is 4. Keep the 4. 4 times 2 is 8. Keep the 5. 1 times 4 is 4. All right. It's not difficult. It's just not on the ACT, so I mean, I don't cover fluffy stuff. All right, question 2. In question 1, did you notice about the y coordinates before and after the horizontal stretch? What do you notice about the x coordinates before? Well, darn, I just covered it. Okay, so when you complete a horizontal stretch, that's along the x-axis. I'm putting that in there so you can remember. The x changes and the y does not. All right, so when you complete a vertical stretch, again, that's along the y-axis, the y changes and the x does not. Can't make it any simpler than that. All right, question 3. In question 1, what do you notice about the x coordinate before and after the horizontal stretch? What do you notice about the y coordinate in terms of x? And well, it's just multiplied by the scale factor. The pre-image will be multiplied by the scale factor for either the horizontal or vertical stretch, respectively. The reason why I put respectively is because you got to remember only one of those values changes, the other one stays the same. So I don't want you to think you're going to multiply both of them by the scale factor, not on a stretch. Only on a complete dilation do you do both of them. All right, question 4. Move the horizontal and vertical sliders some more to stretch the image of the triangle. As you move the sliders, observe what happens to the interior angles. Based on your observations, can you say that it stretches preserve? No, it's not going to preserve angle measures. Only a complete dilation would do that. I mean, look at angle A here at the pre-image and the angle A here. Completely not the same. B right here looks like it's 90 degrees. Probably, maybe, I don't know. But B here, way obtuse. They are not going to be the same. So, no. When stretched, the angles do not remain the same. 5. All right, you guys, so that probably finishes up the activities for this lesson, representing transformations in the plane. If you get stuck on something, you have my email, you have my clever messenger. Just let me know what I can do to help. All right, we'll see you in the next lesson.